till time we have covered 4 modules, and each modules contains the different topics like say genetic programming, collection framework, arrays, and then array data structure like. So, our next module is the 5th module. In this module we will study another new data structure. This is very popular data structure which has many significance so far the real life application development is concerned. It is called the linked list, and in this module first we will try to understand the concept of these data structures from the theoretical point of view, and then we go for a programming practice of this, then how this linked list can be programmed. That means you can write your own program to implement this structure, linked list structure, and finally we will see how the Java collection framework supports to implement the linked list. So, the 3 aspects. Now, today in this lecture particularly we will discuss about how the linked list data structure is there, which is very popular one data structure for the computer science students actually. Now, in this video lectures we will try to cover basic about the linked list structures and then the different operations on it, operations like the usual operations like creating a list, the insertion operation, deletion operation, and finally the traversal is basically visiting all the elements those are there in the linked list. So, this is basically our today's agenda, and now let us first learn about the linked list structure. Like array, linked list is also a linear structure. Linear structure means it basically maintain an order, that is why it is called the order data structure or is called the sequential data structures. But there is a different compared to array structure. The linked list is, the difference is that this linked list, in case of array all elements are sequential, but in a contiguous location. That means in memory they are placed one after another in the memories. But in this linked list structure the elements are not necessary to be in a contiguous location in the memory, they are in random wherever it is there. So, one good advantage of this structure compared to the array is that if you want to store say 1000 elements and for which the contiguous memory location is not possible, then you will not be able to work with this array. On the other hand, linked list structure, as the memory is in a distributed ways, so here and there wherever it is possible, even the memory at one chunk if it is not possible to accommodate 1000, but all together in different locations if you see, then you can do it. So, this is the one way of, that is a order elements, but it is not in the contiguous location like the array it is there. Now, that is why the different the definition, the basic or fundamental definition of a linked list is that it is an order collection like array, is a finite. Of course, you cannot include infinite number of elements, although like array you can contains any number of elements, but unlike array again it can grow automatically, is a dynamically. So, this is the one good advantage compared to the array, and it is homogeneous, means if you can define a linked list it should store only one type of elements in it, whether it is type elements integers, all integers or all strings or all any type user defined, whatever it is there. And then so these are the basically the definition, is a fundamental definition or basic definition of a linked list structure is an order collection of finite homogeneous elements. Now, here few more terminologies that is required. All elements is stored in the form of nodes. So, nodes is an important concept in linked list structure. Now, here as an example we say the node usually has the 2 fields. The one field, first field is the data itself, which data you want to store. So, if you want to store integer or string, you have to define that it is integer or string like this one, and this is called the data field, that means actual content that you want to store. And then the next field is basically link to the next node. The idea is that if you want to store say 10, 15 and 20, then so in the first node it will store 10, another node 15 and then third node 20. Now the first node which stored 10, it basically links to the next node, namely 15. So it basically this field store the address of the next node where the next element is stored, and so on. And at the end this link field should be null. Null means it does not point to any other nodes, indicating that this is the end node. So this is the concept that is followed there in the linked list structure, and the concept that is called the concept of node. Node has the two fields, the data fields and the link field. Link is basically address to the next node. Now I have already mentioned about the difference between the arrays and the linked list. The fundamental difference is that array is a static type, whereas linked list is dynamic, and array the all elements stored in a contiguous memory location, whereas linked list not necessarily. Otherwise they are same, they are ordered, they are homogeneous, whatever it is. Now so this is basically array linked list, and we have learned about the basic concept of linked list and difference between the array and linked list. Now we will see the different types of linked list are there. Different types of linked list means depending on how it can store the elements in it. The types are basically three. There are three types actually: single linked list, the double linked list, and then circular linked list. So there are mainly three different types. We will discuss all these types one by one. Now let us first concentrate on single linked list structure. Now the name implies that it basically contains only one link. One link means it will basically point to only one node. Double linked list means if a node points to two nodes, more than double, again triple nodes also you can, but it is not required, unnecessary, it will make complexity, it will invite complexity in the concept. So usually single linked list and double linked list. Single linked list basically point to a single node, next node only one link. Double linked list means it basically point to nodes, two nodes. Now a single linked list typically look like this. So here is a typical view of a linked list structure. As you can see in this example, as you see 6 nodes are there, each node contain their own data, like this is the one data field, these are the data contents. So 59, 38, 64, and you see there is an order is there, ordering is there. So here ordering that n1, n2, n3, n4, n5 and everything, but they are not necessarily in contiguous, they are here and there. So it basically in memory view it look like this. So 59 is the starting one. So this is the starting element, that is the first node actually, and after these things the 41 is basically indicate the link. So here the link or address of the memory element where the next element, next data is stored there. So 59 is the data, and it 41 indicates that next node is, next node means which is the next element after 59. So 41, so go to the 41 is the 38, then 38 50, that means the link is 50. So go to the 50, you can go 64 and so on, so on. So here you can see in memory we have to store two informations actually. The first information about the data itself, and second information about that the point, the location of the next data actually. And in addition to this, so data and link, there is one more extra node is used. This node is used called header node. So header node is basically a dummy node. It does not include any data, but it basically indicates a link to the start node. So if this is empty or null, this means the link of the header node is null. This indicates that list is empty. Otherwise if it is not null, it points to elements, say non-empty linked list. So this way the concept that is followed in the data structure is that header node points to the first element, and then each node will contains the data of its own and it points to the next node. So, that concept is there, and again you note the last node whose link fit is again null. So, null is in pictorially shown like this way. So, this indicates that is empty, that means this is the end node. So, there is no link, no more elements there. So, this is the concept that I have illustrated to you to understand about the linked list, single linked list structure. Actually, both the conceptually a figure pictorially it shows look like this, and physically. So, this is basically the logical view, and this is basically the physical view of the storing of elements using linked list structures. I can tell one other way, so that a linked list essentially two arrays actually. One array contains the data and another array contains the pointers, but actually in actual implementation or programming you need not to maintain two arrays, you can even single arrays, but here objects or class can be defined, that means node type can be defined. Now, we will discuss about how a node can be defined using, or this is a programming issue will be discussed next video lectures, but today we will discuss about the theoretical point of this one. Now, so this is the single linked list, and then different memory management that can be done very easily, like say you want to insert an element into the existing list, how you can do it. So, here is the idea. So, there are two, actually there is a pool of memory from where the element needs to be, because I told you the linked list is a dynamic structure, it grows automatically. Now, so there is a pool means the memory, available memory is there. So, this basically the memory bank we can say, from where the element will be collected and then that element will be inserted into this one. So, suppose this is the existing linked list going on. So, this is the at any instant the current structure of the linked list, and if you want to add one element into the list, how you can do that. So, first you say that whether the memory is available to accommodate your new data, okay, it is available. So, then the memory manager return that this is the element for you, it can give it. So, this basically newly allocated node for you, and then you can just simply set the pointers which was initially empty to this linked list here, and this can be make null, and then this basically automatically will be added into this one, and then the pointer of this memory will be connected to this one. So, this way memory management, the bank will maintain its memory after giving the memory to you and this one. But here one important thing that you should consider, the pointer management, or that means link setting and everything is an issue. Here for example, we first get this. So, this is basically available node and then set this one, then we can do one thing, we can just change this pointer, the node which point this one will be set by this one. So, this pointer is there and finally, we can make it there. So, this is the first one, then the second is this one, and then finally, third pointer setting is there. If you do not follow in different order or not in other order, then you may come into a wrong way of adding element into this one. So, those things are very important. Anyway, those things we will discuss while we do the programming, and that can be taken care. Now, let us come to, so this is memory management regarding adding element into a linked list. Now, again returning an element into the linked list also can be done in the same way, and here is an idea about how you can return if you feel that okay, this memory needs to be returned to the memory bank, how you can do that. So, here again, here is the one example that how you can return the memory. So, here this is suppose existing structure that you want, that you are having, and at any moment if you feel that this element needs to be returned to the bank. So, how you can do it? So, you know that this is the memory that needs to be returned. So, and this is the memory bank, and memory bank is the last is there. So, first you can set the pointer because it is initially empty. So, you can set this point to this, which basically the node to be returned, and then this can be made null. But before making null, we see that okay, this pointer should be changed to this one because it is returned, and then this is null. So, the first this links needs to be set, then second link to be done, and then third is to be done, and this way you can easily return memory, return a node into the pool of memory. Anyway, so these are the very efficient way, those are the memory allocation can be done and using linked list structure. That is why linked list is very popular and very fundamentally it is used in any system software, any operating system implementation or any application implementation, it is there. Now, let us come to the basic operations that we can do using single linked list. Operations are insertion, how a new element can be inserted. We have already studied about basic idea that how a new node can be added into the linked list, existing list. Deletion operation is basically removing, how we can return if a node is no more required, return to the memory so that other program can use it. Copy, it is just like a copy means making a duplicate. Merging, two lists are there if you want to merge the two lists into a single linked list. And finally, traversing is a very trivial operation so that you can visit the entire list. Visit means either you can print or you can perform some operations on it like this one. Now, let us see how those operations can be implemented or can be carried out theoretically. The programming issues will be discussed in the next class. We will discuss about the insertion operation. Insertion operation that we have discussed in one example, in one slides in this just a few minutes back. Is a very simple one, but there are insertion can be taken place in many different situations. I have mentioned here 3 situations because depending on the situation your operation will be little bit different actually. So, the 3 situations or 3 cases like insertion at front, insertion at end and insertion at any position. Here at any position means after a certain element you can specify that you want to insert after that element. So, these are the basic operations, and now the 3 major steps that needs to be followed. The first step is basically you have to first allocate a new node to add the new elements. Now, here your allocation may be failed because memory may be exhausted, there is no more memory available in the memory bank. So, in that case it will fail. Otherwise, you can go ahead, then start from header node to go whether you want to insert at front or end or position. Now, depending on the situation or cases, you have to just manage the links. So, learning of the different cases of insertion at different situation is basically managing the different links that way. So, we will see exactly how the different cases of insertion operation can be carried out. Now, let us first discuss about insertion at front. Now, so from the memory bank it basically suppose new is available, new node. So, this basically return from which memory location the next element will be obtained. So, new basically return, the memory manager returns node for you and the address of this is say new. So, new is basically address of the newly available node. Once you have it, then you have to go for little bit careful link management. So, you should start from the header as a viewer because header is the right, and you want to insert at front, that means the first element, insertion as a first element actually. So, you have to insert here. So, say suppose this is the new node that is given to you. The first you do is that you just initially when the node is supplied to you from the memory manager whose point this link feed is null. So, you have to set this link feed, this is the first one. How you can set it, which one? Now, you have to go which is the front element if it is there, it may be null. So, there may be situation of course, if it is null then it basically null will be there anyway. So, you just go to the header and from the header know that which is the first element. So, this basically is the first element. This means that the pointer or link of this file will be set by the link of this one. So, this means the header points to this node and this is basically will be set to this one. So, this is basically linking. So, this is the way that you can. So, this link will point to the first node which basically header points it actually. So, this is the first step. So, once we set this, our next is basically. So, now what we have done, so this basically set it and then header should point this element to this one. So, we know that point, this is the address of this next load. So, this point will be, this link will be set by the address of the new node that is given to you. So, this is the second link. So, only two links are to be managed. First is basically link of the newly available node by the first node, that is point by the header, and then second is basically just set the link of the header by the address of the newly available node. So, these two links are to be managed in order to perform the insertion operation at front. Now, next at end, like front, at end is also very easy. What is the idea? Idea again, first let us, this is basically the newly available node which is given to you by memory manager and this is the new node actually, this is the address of the new node is new. Now, you have to go to the end. So, this is basically address or basically link or location of the last node and let it be the PTR. PTR is basically location of the last node. Now, initially this link is empty. So, adding the new node at the end is very simple because you have to set this link by the new address of the new node. So, this is the only one link needs to be managed, and another is that the setting that this should be make null, indicating that the new node which is inserted at the end become the last node. So, only one link needs to be managed in case of insertion of an element into at the end. Now, let us see insertion at any position. There also only two links are to be managed. Now, let us consider this is the new node that is returned by the memory manager. Now, you have to insert after a particular element, let us say this element. So, starting from the linked list header, we have to come to this node and this is the pointer that it points, after which node we have to add it. So, that is fine. In addition to, you have to have this another pointer of the next also, because this is required. Now, what is the link management that is required is that, so this is the new node initially whose link is null. So, you have to set this link by this link. So, it is basically set this one. That means, this link should be initialized with the address of this node. Fine, this is done. Next is basically the link of this field should be set by the new node. So, this link which initially points to this one, we just set this link field by the address of this field. So, this is the second link that needs to be managed. So, by this process you can see you can lose the link from this node to node, rather you can set the link from this node and from this node. So, the new node is added at this position like this. So, this basically it is there. So, this is the concept that insertion at any position can be done. So, this is all about the three cases of insertion. Now, next come to the deletion operation. Like insertion, deletion operation is a matter of link management. Now, like again insertion operation, deletion can be according to the three different cases: deletion at front, deletion at end, and deletion at any position. Again, three steps that needs to be followed. First, you have to start from the header node, where to insert. If it is front, be there. If it is end, come to the end node, and if it at any position, you search that where you have to go. If you find the position, then you can add it, and then finally return to the memory bank, the node that is deleted. Now, let us see the example that you can do it of three different cases here. First, we will elaborate about deletion of a node at front. Now, here is the this is basically your initial linked list that is given to you, and we want to delete this node. That is our objective. So, what you can do is, first starting with header, we have to go to the first node and let this is basically address of this node, PTR is basically address of the first node. Then what we do is, first what link needs to be managed? First is basically we can have the address of the next to next, that means second node, first node this one. So, this node is needs to be tracked first, so that we can have it. Then the header node should point to this node. So, header node will point to this node. By this process, the link from header node to the first node is lost. So, this basically lost then. Next, basically we have to make this pointer is null. So, that is all. Then what happens is that this is become freely available, and the next linked list is basically like this one, and we can return this node to the memory bank. So, this is the procedure that we can follow. Only one link needs to be managed, I mean setting, and other is basically setting the null. So, this is about the deletion of a node at the front. Now, we will discuss about deletion of node at end. It is again similar to the front, it is very simple. So, initially given this is basically your list as a whole, and you want to delete this node which is the end node, that is basically the case. Now, what actually you want to do is that you have to come to the last node. So, this is the pointer here, and before the last node, this node needs to be also keep a track. So, like the front, we have to keep a track of the header, then next node, like this one, front node, next node, here again end node, and before the end node this one. So, PTR and PTR are the two pointer needs to be stored there. Then the deletion can be accomplished by setting the link only. So, first it is already null, you do not have to set anything, only what you have to do is that which nodes is the PTR 1 is basically link field of this to be set as a null, that is all, and then this is basically okay. So, now your link is like this one, and this basically is a free, you can return this free to the memory bank. So, this is the case of operation deletion in this case, and our next operation is basically deletion at any position. Now, this operation again, initially this is the list that is given to you, and you want to make free this node having key that you want to get, right, and what you want to do is that this node you have a track. So, here you have to keep a track of before this node is there. So, two pointers needs to be maintained here. One is the node which needs to be removed, and the nodes which has to be removed just before this node, and you know that this node address needs not to be tracked. So, these two pointers have to be tracked first. After traversing from there, you can come here. So, that can be recorded. Now, what modification of the link that we should do is just simply we know actually knowing this node, we know the pointer of this node because this one. So, this is the address which basically map the next node. We should set this address by this one. So, this basically the link that to be, that means we can change the address of this node, address or link, the field link field of this node will be set by the address of this node. So, this can be done, and by doing this you basically lost this information, that means this node does not indicate this one, point this one. Okay. Next is this pointer is free and we have to make this basically is a null and then return. So, this become free and you can return to the memory bank. So, this is the idea about deletion at any position. Again we can see only you have to keep track of the different nodes that needs to be taken into consideration while we are doing deletion operation and then managing the links. So, in most of the cases, as we see in case of deletion only one link needs to be set and then another is basically the node that needs to be returned, his link to be marked as a null, that is all. So, these are the basic operation that you can do. So, for the deletion operation is concerned, merging operation is quite simple. If you are familiar to delete, merging operation is there. For example, here two lists, this is the one list and this is the another list is given to you, and we want to merge this list after this list. Then here the what operation you can do is that from this header we know that this is the pointer. So, what you can do, this is the null field, we will just simply set this pointer to here. This way we can lose this pointer. So, empty and then return this header because this header is not required to memory bank, and then this way what you can do is we can just do the merging of the two of list. So, it is quite simple, only one link needs to be managed here. So, this is called the merging operation. Now, let us come to the circular linked list, what exactly the circular linked list looks like. Now, in case of single linked list that we have learned about, if it is the single linked list look like, then the last node or the node which is at the end having the field link field is empty or null. But in case of circular linked list, as we see, it basically the last node basically indicates to the header node. Now, if you can traverse it and you can just starting from the header, in case of single linked list we will go to the only last node, but in case of circular linked list starting from the header you can reach to the header again. That is the difference between the single linked list and circular linked list. In case of single linked list you can never return to the header because it basically gives you one way movement, but in case of circular linked list you can come back to the header and again repeat the traversing like this one. In many situations it is useful, but application is a different issue, but I just discussing about the concept of this list. So, this is the concept of circular linked list. And merging of the two circular linked list again simple, like the single linked list merging is there. Now, here as an example, so this is the one circular linked list and this is the another circular linked list. I want to merge two circular linked list into a one circular linked list. So, how we can do that? So, here basically we can know that which is the last node by this one. So, somehow we can have this is the last node of this circular linked list and this is the last node of the circular linked list. Last node means the node which points to the header is the last node. Here the node which points the header is the last node. Now, setting is very simple. So, first what we should do is we can set this pointer to this one. So, this way it comes there. So, this way it basically comes to this and then set this pointer to this one. So, this way just okay, two setting is there. Now, there are opposite way also you can do. We can merge this list before this list, then opposite way the link can be managed. So, this is basically merely managing the link, and then you can do, and after the merging the last node can be written. So, this is the merging of circular linked list. Now, we have discussed about single linked list and discussed about the different operations on it, namely insertion and deletion, and circular linked list is also the concept is now we have learned about. If you want to learn many more things about these linked list structures, I should suggest you to go through this book. You can find it there, and details operation and everything will be there, application of different structure will be there. In our next video lectures, we will discuss that other linked list structure, namely double linked list, and the different operations of it. So, this is the topics for today. Thank you.